Alright, we are doing two sections today. Section 6.3, Section 6.4. Similarity in triangles by angle, angle, side, 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 and side angle, angle. Side angle, side. So, the first one here is a postulate, and it's called the angle postulate. And what the angle postulate says is that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are congruent. This is angle, angle. Are similar. So this is angle, angle. If two angles of one triangle are congruent to two angles of the other triangle, then the two triangles are similar. So the example of that, we got two. Here we have two triangles. They all have the same angle. We have two triangles. They all have the same angle. These guys are equiangular. These guys are also equiangular. So, corollary to base angles theorem, or how isosceles triangles theorem says that if you have a triangle that's equiangular, then it's equilateral. If you have a triangle that's equiangular, it's equilateral. So these two triangles all have the same sides. But in addition to that, since I know that they're all the same, we can call this angle, let's do this, x, x, and x. We know that the sum of interior angles add up to 180. So 3x equals 180, x equals 60. If you look at the bigger triangle, we have y, y, y. We can say that 3y equals 180, and then y equals 60. So they all have the same angles. All three angles of the big triangle is 60. All three angles of the small triangle is 60, which means that at least two of them are congruent to each other. Therefore, these guys are similar because of AA. So both triangles have 60 degrees. Therefore, therefore, they are similar because of AA. Two angles here, at least, are the same as two angles here. Therefore, they're similar triangles because of angle, angle. Similarity. Alright. We have this triangle here. This is 58. This is a right angle. We have another triangle here. This is a right angle here because these form a linear pair. This is 32. So if I look at the triangle at the right, 90 plus 58 equals 148. 180 minus that equals 32. So this is 32. And if this is 32, then this is 58 up here. So I have 1, 2, 1, 2. These guys are all congruent. Therefore, these triangles are similar because of AA. So triangle CDF is similar to triangle DEAF because of AA. I have two angles that are congruent, and since I have two angles that are congruent, then I can say that they are similar. So let's look at a couple of these examples actually from the book because these are pretty good. So if we look at this, and you'll probably see it again, you know what I mean, in your homework. If you look at this, we got D, E, A, B, and C. We have this as 52. We have this as 52. So we have the smaller triangle, EA, A, B. We have the bigger triangle, DAC. There's a 52 here. There's a 52 here. They both share the same angle A. And since they both share the same angle, this guy and this guy is congruent. So now we have at least two angles that are congruent, so we can say that these two triangles are similar because of angle. Again, I have two angles that are congruent. I have angle B congruent to angle C, and then because they both share angle A is congruent to angle A. Therefore, they are similar triangles. And then this guy, we're told that this guy and this guy are parallel. We got a S, V, R. We got a T, U. They're alternating interior angles because these two guys are parallel. Here's my transversal. So I can say that S is congruent to U, alternating interior angles. I can also say, if I wanted to U is congruent to R. And then I can also say that since these are vertical angles, these guys are congruent. So I have the pick of two sets of angles. So these two triangles are definitely congruent. So triangle SBR is congruent to triangle UVT because of angle. Okay. Here we have a person and a flagpole. And I guess the sun is casting a shadow. So here's the person who is 5 feet 4 inches. That casts a 40-inch shadow. Here is a flagpole. We don't know how tall the flagpole is in feet. That casts a 50 feet shadow. we can convert 5 feet to 4 inches to 5 times 12 is 60, plus 4 is just 64. So if you notice the units in the top is feet, well, the units in the bottom is inches. So essentially this is big, meaning the flagpole, over small, meaning the person. Actually, it's big person. I'm sorry, big pole, small person is proportional to big shadow, small shadow. So this is where this equation is coming from. So we don't know what the size of the flagpole is, so that's the x, that's where it came from. The size of the small person is 64 inches. So this is feet over inches. So our units have to be feet over inches over here. Otherwise, it's not going to work. So the shadow of the flagpole is 50 feet, big on top. And then the shadow of the person is 40 inches. And then you can cross multiply, and they got that x equals 80 feet. Okay. Using that same thing in mind, they say that there's a child who is 58 inches tall. So the child is 58 inches tall, small person. We know the size of the flagpole now, which is 80 feet. We want to know the shadow. We don't need to know what the shadow is of the person, small shadow. So cross multiply, 80x equals 50 times 58, which is 2900 divided by 80. And we have 36.25 inches, or 36 and a quarter inches. Yeah. And it says that you are standing in your backyard. And you measure the lengths of the shadows cast by both you and the tree. Write a proportion showing how you can find the height of the tree. So it's very similar to what the other problem did. Very similar to what the other problem did. So much so that I'm going to keep this part up there. So instead of saying the height of the pole, I'm just going to say the tree. Right? And then the height of the small person, and then big shadow, small shadow. Or you can say the tree shadow versus the person's shadow. And that would be your proportion for that particular problem. Just set that up. Alright. Hey guys, that's 6'3". Real quick. And then 6'4", which is two more theorems. The first one, side, 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 and side, angle, side. So side, side, side says that if And this is of triangles, of course. Side of triangles, similarity theorem says that if the corresponding side lengths of the two triangles are proportional, then the two triangles are similar. So what this means that is all the sides, the corresponding sides of the triangle are proportional to its corresponding other triangle. Those two guys are proportional. That's called side, side, side. Similarity. So, uh, that's the proof of it. I'm not going to require you guys to prove side, side, side similarity. So, hallelujah and stuff. Down here, we have three sets of triangles. Only two of them are proportional, are similar. So we have to find proportions to all these guys. So if we look at M, L, N, this is 20, 26, 24. This is the smallest, this is the medium, this is the large. So I'm going to rearrange the other triangle here or along those same proportions. So the smallest, this is the smallest here. I'll say that this is the smallest here, 24. This is the largest. I'll say this is the largest at 33. And then 30 is in the middle. So so 30, which is R to T to S. Okay. R S S T R T. Okay. So that's that. And then we can draw the third triangle. And these triangles aren't to scale. And do the same thing. So the smallest guy would be over here. The largest guy would be over here. And then the medium guy would be over there here. So the smallest guy would be Y to Z, and this would be X. No, that doesn't make sense. Because it doesn't make sense. This would be Y to Z. Y to Z. Y to X would be 39. That's weird. Oh, no, because I'm wrong. Biggest side over here, medium side over here. Get that. Figuring things out on my own. Alright, so Y to Z. There we go. To X. Nice. Okay. So we'll just set up the proportion. We'd have to do two sets to make sure that this works. So we'll call this, we'll do this 1, 2, and 3. We'll do, instead of small to big, since there's 3 triangles, we'll do from 1 to 2 and set up that proportion. And then down here, actually I'll do the 1 to 2 up here. We'll do 1 to 2, and then down here we'll do 1 to 3. And if these guys are proportional, then we'll be fine. And it will set up the corresponding that way. Triangle 1 to triangle 2. Alright, so smallest side here, smallest side here. So that would be LM to RS. Should equal if they're similar. Small, small, medium, medium. MN to RT, which should equal LN, which is the biggest side, to ST. So this would be 20 over 24, which is equal to 24 over 30, which is equal to 26 over 33. And these guys should be proportional, so let's see what happens. 20 divided by 24, 0.83. 24 divided by 30. Ooh, 0.8. They are not proportional. And then 26 over 33. 0.79. So, nope. Nope. Alright, so they're not similar. Okay, not similar. Not similar at all. Not even a little bit. Okay, so now over here, when we do that, I mean, it's a good chance that these two guys are similar down here. So let's check it out. So triangle 1 to triangle 3. So small side, so LM over ZY, MN over YX, and then LN over ZX. So this is 20 over 30, 24, 36, 26, 39. Hello. Alright, so here I get 2/3, 2/3, 2/3. They're all the same. So these guys are similar. So triangle MLN is similar to triangle YZX. So the way that I set up my sides was short, medium, and large. This is the shortest, this is the shortest, this is the shortest, so I set my proportions accordingly, or my ratios. This was the largest, this was the largest, this was the largest, and then this was the medium size, this was the medium size, and this was the medium size. And that's how I set up my triangles so that they could align up. So I used the sides, the measurements of each sides of the triangle to set up my ratio so that when I did the proportions to see if they were similar to each other, then it aligned up. Alright, we have triangle RST from the previous action. S and T. So from R to S is 24, S to T is 33, and then this is 30 r to t. Okay. And it's similar. The shortest side of the triangle is similar. Okay. The shortest side of a triangle similar to RST is 12 units long. So we have some other triangle. We don't know what it's called. We can call it ABC. And the shortest side of this triangle is 12. So, knowing that, let's find the other two similar sides. So if we do this and say 12 AB over RS, which is 12 over 24, which is 1/2. What I can do is I can find the other sides by multiplying this by 1/2. So AC, I can find AC by, I mean, we could set up a proportion and say that, let's see, so we can say that AC over RT is equal to AB over RS. So that's X over 30 is equal to 1/2. And then 2x equals 30, x equals 15. So basically I'm dividing it by 2. So this would be 15. Alright, and then we can do the same thing for BC. So again, BC would be AB over RS is equal to BC over ST, and that would be 1/2 equal to X over 33. So then that would be 2x equals 33. 33 divided by 2 is 16.5. Yeah. So since I was told that they were similar, they gave me one of the sides for one. I can set up a proportion for the others and find the other two sides of that similar triangle. Alright, and this leads us to our last theorem of the day, which is side angle side similarity, which says that if two triangles are similar, the two sides and the included angle of one, just like side angle side, has to be proportional and congruent. So if I had a triangle, one big, one small, they call this guy ZX, XYZ. They call this guy MNP. This guy and this guy are congruent. And then the included sides, or the sides included in that angle. So these two guys would be proportional, and these two guys would be proportional. So, angle, and then the two sides that include that angle are proportional. So these two guys are congruent. So angle X is congruent to angle M, and in addition to that, XZ over MP is a proportion with xy over mn. Then I can say that these two triangles are similar. Side angle side. The included angles of the two sides have to be proportional and the two angles must be congruent. If one angle of one triangle is congruent to an angle of the second and the lengths of the sides including these angles are proportional, then those two triangles are similar. Okay, so these are the three theorems and or postulates that we've done in the past two sections. Angle, angle, side, 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 where all three sides have to be proportional. Angle, angle, at least two has to be the same or congruent. Side, angle, side, two angles are congruent, and then the included sides, or the angles included with those sides, have to be proportional. Okie dokie. 3 and 5. Alright, explain how to show the indicated triangles are similar. Okay, so for this one, we have the 90 degrees. We have the two angles here, and they look to be included. So we're going to get a proportion from small to big. So we have the bigger triangle. RST. This is 24. This is 28. We have the smaller triangle. NPQ. This is 18. This is 90. Oh, Jesus. This is 21. Okay. Alright, so we already have one of the conditions for a side angle side. So angle R is congruent to angle N. This is big, this is small, so we go from big to small, which is going to be SR to PN. Must be equal to RT over NQ. And if you're wondering why I'm choosing this to that, this is the smallest over here, this is the smallest over here, this is the biggest over here, this is the biggest over here. So that's how I align mine up. And that gives me 24 to 18. And that gives me 28 to 21. And these guys should be the same. So this is 1 1/3. So 4/3. And this should be 4/3 too. And it is indeed 4/3. So they are the same. They are proportional. Therefore they're similar because of side angle, side similarity. Okay. Over here, we have two triangles. Let's do the same thing. This is 90 degrees. For this bigger triangle, this is my shorter side. This is my longer side. This is my medium side. So W, Z, and X. Alright, for my smaller triangle. Okay. This is my smallest side. This is my longest side, and this is my medium side. So that's going to be y, x, z. Okay, they both share angle z, so angle z is congruent to angle z, so that's good. And again, I'm just setting up my triangles according to longest, biggest, shortest side. So this is big to small. And that's going to be, I'll do 12 to 9. And then, or actually, my bad, xz over yz must be proportional to zw over zx. So that's going to be 12 to 9 must be equal to 16 to 12. 12 over 9 is 4/3 again. That's interesting. 16 over 12 is also 4/3, so they are proportional. So the included, the two sides are proportional. The included angles are congruent. Therefore, they are similar. Triangle XWZ is similar to triangle YXZ. And they're similar because of side angle side similarity. Okay. All right. That is that section. I hope you have a great rest of your day.